Namaste everyone. Hope all of you are well. One of my friend have suggested me to make video on chemical kinetics. I hope this will give you benefits in understanding the equilibrium, chemical equilibrium or ionic equilibrium. Actually, whenever we study, just three parts is together in the syllabus of IIT JEE and NEET: chemical equilibrium, ionic equilibrium, and chemical kinetics. These three things, whenever you go from the basic concepts, it will help you to crack JEE, NEET, or any advanced level questions. So let us begin with chemical kinetics. So first of all, what is chemical kinetics? Can you tell me? Any one of you. What is chemical kinetics? It is a physical chemistry branch that you know very well. That branch of physical chemistry in which we deals about the rate of reactions, the mechanism by which the reaction and factors affecting to the rate of reactions. Just remember that this is the branch of physical chemistry in which you have to understand the concept of rate of reaction, the mechanism of the reactions or the factors which affect the rate of reactions, right? Now, on the basis of rate or chemical reactions, it is specially divided into three categories. How many categories? Three categories. If I talk about, there are three categories. One is very fast reaction, or you can say instantaneous reaction. Another is very slow reaction, and third one is moderate or slow reaction. If we talk about the reaction types, rate of reactions, how the rate of reaction occurs. So first one is very fast reaction. Can you tell me was that any reaction in which the rate of reaction is very fast? I hope that I have informed you in the chemical equilibrium that ionic compound especially gives fast reactions. The reaction involves ionic species. If we talk about the fast reaction, then we can say the reaction which involves ionic species is known as ionic reactions, and these reactions take 10 to the power minus 14 or 10 to the power minus 16 seconds for completion. That's why it's very fast. 10 to the power minus 14 or 10 to the power minus 16, you can understand. So it is almost impossible to determine the rate of reactions. If I give you an example, silver nitrate and sodium chloride, AgNO3 plus NaCl. When you treat sodium chloride with silver nitrate, it will give you the silver chloride precipitate and sodium nitrate compound. Silver chloride precipitate, that ionic compounds, very fast rate of reaction. Silver chloride is white precipitate. Similarly, if I talk about another example, you can take a barium chloride. When you do reactions of barium chloride with sulfuric acid, it gives you barium sulfate plus hydrochloric acid. This barium sulfate also gives white precipitate. When you do this reaction, that time you will understand. Similarly, if I talk about that sodium chloride salt, it is formed by the mixing of hydrochloric acid and sodium hydroxide. It gives you sodium chloride and water. So these are the examples of very fast reaction or instantaneous reaction. Now if I talk about the second type of reaction, that is very slow reaction. Very slow reaction means, you know, when you do painting in your grills, and when your iron grills comes in the contact of water and oxygen, then they get a rusting of iron. Yes, so rusting of iron, you can say it is a very slow reaction, or you can just define slow reaction as it occurs very slowly. It takes month or more than months, or it is very slowly measurable change at the room temperature. Now if I talk about the example, as I have told you, that rusting of iron, or at the room temperature hydrogen and oxygen, this both mix and form water, or you can say carbon monoxide or hydrogen, when they both mix and form a methanol at the room temperature. So these are very slow reaction, very slow. It takes more than month to occur. And third one is moderate, or you can say it is also a slow reaction. This type of reaction especially proceed with the measurable rates at the normal temperature, and we can measure the rate of reactions very easily. Most of the reactions are molecular reaction in nature. If I talk about hydrogen peroxide, this hydrogen peroxide converts into water and oxygen. Means it is a decomposition reaction, you can say. If you decompose hydrogen peroxide, it will convert into water and oxygen. Similarly, N2O5, nitrogen pentaoxide. If you decompose nitrogen pentaoxide, it converts into NO2 and O3. Sorry, NO2 and O2, not O3, NO2 and O2. If you want more examples, then you can do hydrolysis of ester. Hydrolysis of ester means ester, when you do reactions with sodium hydroxide, it gives in the form of products sodium ethanoate and ethanol. Similarly, inversion, you can say sugarcane. Sugarcane, when you mix the sugarcane into the solution, water solution, it becomes aqueous solution when you mix sugarcane into the aqueous solution. So these are the examples of moderate reactions. So first of all, what I have told you, that chemical kinetics is a branch of physical chemistry in which you get a knowledge about the rate of reactions, how many types of rate of reaction, what are the mechanism of rate of reaction, what are the factors affecting the rate of reaction. Now first of all, tell me, what is rate of reaction? Rate of reaction is the change in concentration of reactant or products by time taken to change. That is only the rate of reaction. Yeah, you can define as the change in concentration or pressure of the reactant and product per unit time is called rate of reaction. Now the change in concentration, you can just write in the formula rate of reaction, R is equal to delta C upon delta T. This delta C is change in concentration, means there will be a change in concentration by time taken to change, that is delta T. Plus minus, I have told you, as I have taught you in the chemical equilibrium, that why there is a plus and why there is a minus. If you don't know, then I just want to tell you, when the reactant decomposes, or you can say there is a dissociation of reactants, so that's why there will be a negative symbol for the reactants and positive symbols for the product. So that's why plus minus delta C by delta T, R is equal to plus minus delta C upon delta T, that is change in concentration by time taken to change. Now if I talk about how many types of rate of reactions are there, it's very easy to understand. There are average rate of reaction, instantaneous rate of reaction. Similarly, as I have told you, that if I talk about that average rate of reaction generally which will occur, take a chemical reaction that A is a reactant and B is your product. So what will be the value of that R average or rate of reactions average? That is equal to change in concentration of the reactant by time taken to change. Means if A is there, so A will become A2. Earlier it was A1. So A2 minus A1. Concentration of A2 minus A1 upon time taken to change, T2 minus T1. So you can say that delta A upon delta T. If a reaction is A to B, then you can directly write delta A upon delta T. Concentration of reactant A at time T1, A1 at time T1 and A2 at time T2. That is why A2 minus A1, that's delta A upon delta T. If I talk about instantaneous reaction, then in the instantaneous reaction, remember the word, the rate of reaction will be minus delta A upon delta T, limit where delta T tends to 0, that is plus minus dC upon dt. Or rate of reaction in the form of stoichiometric in a chemical reactions, rate of disappearance, and rate of appearance. Disappearance in the form of reactant side and appearance in the form of product side. So these are the rate of reaction if I talk about the unit mole per liter. Similarly, I will describe more about this rate of reactions after this video. First of all, this is an introduction of chemical kinetics. Definitely, I hope that you have started chemical kinetics. And it's very easy, no need to worry. I'll teach you all the fundamental methods of rate of reaction, so you can understand how I'm teaching you instantaneous rate of reactions, or you can say slow, high, instantaneous average reactions.